Good morning, students. We have a busy period ahead of us. We're solving systems of equations using a new method today called substitution. So I'm anxious to share that with you. But first, we do have our do now, where we'll carefully answer a prompt about relationship deposits. Our objective today is to use substitution to solve a system of equations. And our essential question: how does substitution work? And what are the steps required to solve a system of equations using substitution? Our assignment today, when we watch the video, will be to work 2 assigned pages. And show your work, please, when you complete each one of these problems. There's quite a bit of work to be shown in these. And for our exit ticket, we will go through the 3 steps for solving a system of equations using substitution. Our homework tonight, homework 5.2, solving systems using substitutions. There are 2 pages, 16 problems. And remember, to get full participation credit, let's have your camera on. Respond when your name is called at the beginning, middle, and end of the period. Submit your completed lesson by end of day through Teams. There will be an assignment there waiting for you. And if you have questions, make sure you email me. Looking forward, we just want to remind you that we have a full day of classes on Wednesday. So dial into every one of your periods this Wednesday. And then on February 4th and 5th, we're going to begin our map testing. So let's get started with our lesson. Well, let's get started with our do now and then our lesson. So in our relationships with others, we can make deposits, positive actions or words that improve our relationships. What kind of an act would be a good relationship deposit? Does a relationship deposit have to be hard? And there's one thing I've learned from listening to you, and as we've talked about all these different social and emotional topics, is that one thing that you guys have identified over and over again is the value of just being there and being a listener. That's what I've learned from you. And I think that is one way to really make this relationship deposit. We think of a deposit as a bank account deposit or saving money somewhere, but it makes sense that we would have a relationship deposit. And, it doesn't have to be work, right? And you don't have to keep an account. Oh, I did something for you, now you did something for me. Just try to be a giving and loving person and keep making deposits into every relationship you have. And as you do that, those relationships will become really rich and really enjoyable. So there's so many ways to make a relationship deposit, but I'd love you to answer right there and put your spin on it. It's always a joy to know what you have to say. So we'll come back to our exit ticket in a minute with the 3 steps for solving a system of equations with substitution. But let's get started right away. So our topic today is using substitution to solve a system of equations. So what do we mean? What are we talking about? What exactly is this substitution method? Well, it is a method of solving systems of equations by substituting equations within or inside one another. Right there within, inside. And you'll see how these equations kind of fit like a hand in a glove. So we have 3 steps. Step 1, you're going to take one of the equations, and you'll see in number 1 there are 2 equations there. So we're going to take one equation and we're going to solve it for either x or y. So you ask, well, which is it? That I will show you during the lesson how to evaluate for whether you want to solve for x or whether you want to solve for y. Very often it'll jump out at you and you'll see which one you should solve. Step 2 is to substitute. So once you've solved one equation for x or y, substitute this expression into the other equation and solve for the remaining variable. So substitute this expression into the other equation and solve for the variable. Now, once you've done that, in step 3, you're going to go ahead and substitute your answer into the revised equation from step 1 and solve for the other variable. So there's a lot of substitute and solve, substitute and solve, substitute and solve. That's what we're doing here. So it may look a little bit like mumbo jumbo to you right now, but when we do a few, I think it'll become a little bit clearer. So let's start with problem number 1. We have 2 equations. We have y equals 4x minus 1 and y equals 2x minus 5. We see that both of those equations are in slope-intercept form, and they are both solved for y. So step 1 has already been completed for us, okay? They're both solved for y, so we'll leave it at that. So we're going to take this expression of y, 4x minus 1, and we're going to use, in step 2, we're going to substitute 4x minus 1 into the other equation for y. So if it tells us in the first equation that y equals 4x minus 1, then it makes sense that we can substitute 4x minus 1 for y, and then, so this is our new y. Okay, instead of y, we have 4x minus 1. And then we just finish writing the rest of the equation equals 2x minus 5. So now we just want to solve for x. So let's bring 2x to the other side. So we'll subtract 2x from both sides. And that means 2x minus 1 equals negative 5. And the next thing we'll do is we'll add 1 to both sides. 2x equals negative 4. Divide both sides by 2, and x equals negative 2. Okay, not finished yet. Okay, we're only partly there. So we've substituted the expression into the other equation and solved for the variable. Now we're going to substitute, we're at step 3, this answer into the revised equation and solve for the other variable. So I'm going to take this negative 2 and I'm going to substitute it for x. I'll use that second equation. So y equals 2 instead of x. I have negative 2 minus 5. And negative 2 times 2 is negative 4 minus 5. And y equals negative 9. So we've got now an x value and a y value. So the solution to this is negative 2, negative 9. Now, if we go and let's take a look at some of these equations. I've gone ahead and I've done a little bit of graphing in Desmos. So let's turn on the first 2 equations. We have y equals 4x minus 1 and y equals 2x minus 5. And if 4x minus 1 is red, 2x minus 5 is the blue line, And if I look at the point where they meet at, let me get it exactly right, oops, -2, -9. So we can prove our algebraic work by graphing the equations and seeing if we get the correct solution. So let's do the second one together, and then you should try a few on your own. So we have y equals 6x. And then we have the next equation in standard form, ax plus by equals c. So since we are already solved for y, step 1 is completed for us. So I'm going to take 6x, and wherever I see y in the next equation, I will substitute with 6x. So that will give me 2x plus 3, and instead of y, I'm going to put 6x equals -20. The next thing I need to do is this multiplication here. 2x plus 18x equals -20, and then I can combine like terms. 2x plus 18x is 20x equals -20, and then I divide both sides of this equation by 20, and x equals -1. Now I'm going to substitute x equals -1. I'll go right into this first equation because it's really easy. Y equals 6 instead of x. I put -1. So y equals -6. Okay, so my set of ordered pairs, -1, -6. And if you were to graph that, you would find that that indeed is the correct answer. So why don't you go ahead and try 3 and 4, and then come back to the video and see how you did. Okay, so for number 3, I see that the first equation is already solved for x. For y. So I'm going to go ahead and go with that. So I will substitute x plus 9 for y in the second equation. So 3x plus 8 instead of y. I almost wrote y. Let's even change the color. I want to make sure you can see this. So I'll have x plus 9 equals -5. So the first thing I need to do is distribute here. 3x plus 8x plus 72 equals -5. Then I'll combine like terms. 11x plus 72 equals -5. Now I will subtract 72 from each side. 11x equals -77, and when I divide both sides by 11, x equals -7. Halfway there. Now I'm going to take the -7, and I'm just going to go ahead and substitute it for this x right here. So y equals, use parentheses, -7 plus 9, so y equals 2. Now let's put them together. Our x value, -7, our y value, 2. And that's our final answer. Now number 4. Number 4 is already solved for x. We have x equals this quantity of 4y plus 7. So I'm going to take this quantity 4y plus 7 and substitute it for x in the second equation. So 2, and then I have my parentheses. I'll just write it out and come back and make the substitution. So here this would be my 4y plus 7 And then I'm going to go ahead as I solve. I'm going to distribute first, which will give me 8y plus 14 minus 6y equals 12. Now I can combine the 8y minus 6y to get 2y plus 14 equals 12. And then I'll subtract 14 from each side. 2y equals negative 2. I'll divide both sides by 2. And y equals negative 1. And then I'm going to take that negative 1 and I'm going to go ahead and substitute it. So if y equals negative 1, I'm going to substitute it for y in the first equation. That's a much easier equation to work with. So x equals 4, and I'll make the substitution. And I'll put negative 1, okay? So that was my substitution. I substituted negative 1 for y in the first equation. And I just evaluate. 4 times negative 1 is negative 4 plus 7, and x equals 3. So our ordered pair, our solution to this system of equations is 3. Remember, we solved for y first, so 3 goes in the x spot, and negative 1 goes in the y spot. 3, negative 1, and that's our solution. And remember, you can always graph these on Desmos or by hand if you have graph paper, and check your solution that way. So I'd like you to go ahead and try number 5 and 6, and I think we'll do number 7 together. So try those. A hint with number 5, you're going to have to solve this. What I would do is solve this first equation for y. So I'll try it first, come back to the video. Okay, let's get started. We need to solve 2x plus y equals negative 2. So we have to solve that for y. So I'll subtract 2x from each side to give me y equals, I'm using slope-intercept form, negative 2x minus 2. So I'll write that over here. Now that I've solved for y, I can go ahead and use this quantity and substitute it for y in the second equation. So I will have 5x plus 3, and I'll leave room for my substitution, equals negative 8. So this will be negative 2x minus 2. The first thing I need to do is distribute. 5x plus, well, we have 3 times negative 2, so it's not going to be plus, it's going to be minus. So it will be 5x minus 6x minus 6, 3 times negative 2 is 6, equals negative 8. Let's combine 5x minus 6x, which is negative 1x, and the 1 will be invisible. So negative x minus 6 equals negative 8. Let's add 6 to both sides. And we have negative x equals negative 2. And then we divide each side by negative 1. And x equals 2. Now we'll make that substitution, that 2, we will substitute in, let's go to our slope-intercept version, okay? We have it up here as well. Let me, here is our slope-intercept version. We're going to use that equation, and for x, we are going to substitute 2. So y equals negative 2. Now we're substituting 2, use parentheses, minus 2. So y equals negative 2 times 2 is negative 4 minus 2. Y equals negative 6. So we've got 2, negative 6, and that's our ordered pair. And number 6, we also need to put one of these in slope-intercept form. And I have 2x minus 3y equals negative 11, and I have 2x plus y. So y is already unencumbered by a coefficient. So I think this is the equation that I will put in slope-intercept form. So I'm going to take 2x plus y equals 9. I'll subtract 2x from each side. Y equals negative 2x plus 9. So now that I have solved for y, I will take that expression for y and put it in the first equation. 2x minus 3, let's change our color, and instead of y, I have negative 2x plus 9. Equals negative 11. And now we need to distribute. So it will be 2x, negative 3 times negative 2 is positive 6x. Negative 3 times positive 9 is minus 27 equals negative 11. We can combine 2x and 6x for 8x minus 27 equals negative 11. We can add 27 to each side of the equation. So ultimately we want to isolate 8x and then we'll isolate the x. So 8x equals 16, and we'll divide both sides by 8, and x equals 2. Now we'll take that 2 and let's go ahead and substitute it for x in this equation here. So we have 2, and we're going to make that substitution for x plus y equals 9, because this time we are solving for y. So x equals 2. So you know what I should have done? I should have used my slope-intercept form. I think that would be easier. Well, it should work either way, but I should have used my slope-intercept form. So, but I can do it this way. 2 times 2 is 4, plus y equals 9. And I subtract 4 from both sides, and y equals 5. So I've got an ordered pair of 2, 5 as my final answer. So we have something a little bit new in number 7. So let's get started and I'll show you what's going on with that. I'm going to take the first equation and I'm going to solve it for x. So x plus 5y equals 4, because it's almost solved for x. All I need to do is move 5y, subtract it from each side so that I have x equals negative 5y plus 4. And then I'm going to take that quantity, negative 5y plus 4, and I'm going to substitute it for x in the second equation. Substituting for x, negative 5y plus 4 plus 15y equals negative 1. So first we distribute. I'm going to change my color. So 3 times negative 5 is negative 15y. 3 times 4 is 12. plus 15y equals negative 1. So if I combine the negative 15y and the positive 15y, they equal 0. So I have no y's left. What I have left, they cancel each other out. So what I have left is 12 equals negative 1. Okay, of course we know that's not true. 12 does not equal negative 1. So what's happened here? What's happened here is there's no solution. So let's take a look at these two graphs on Desmos. So I'll turn off my first two, and I'll put the second two. So we've got the x. I've entered them as they were original in the problem. So we have the x plus 5y equals 4, the purple line, and the 3x plus 15y equals negative 1, the black line. And what you see is they're parallel lines. In fact, if you solve them for y and put them in slope-intercept form, we would see that they each have a slope of, looks like negative 2. So they have the same slope and they're parallel. They will never cross. And if they never cross, then there's no solution to the problem. There's no place where these two lines will come in contact with each other. So therefore, for this problem, there is no solution. Okay, so why don't you go ahead and do number 8 and 9, and I do want to talk about number 9 for a minute. So try those and then come back to the video. Okay, for number 8, I'm going to go ahead and solve this for x. So x plus 4y equals 0. Subtract 4y from both sides, and x equals negative 4y. So now I'm going to take this 4y and I'm going to substitute it where I have x in my problem. Oops. 3y plus 2y. Okay, so I'll distribute. Three times negative 4 is negative 12. Y plus 2y equals 20. And negative 12 plus 2 is negative 10. Y equals 20. Divide both sides by negative 10. And y equals negative 2. Now we'll take the negative 2 and we'll substitute it. I'm going to go to the slope-intercept form. I'm going to take the negative 2 and substitute it for y and solve for x. And here I'm going to substitute the negative 2, and x equals 8. So we have our negative 2 for our y value and our 8 for our x value. 8, negative 2. Done. Okay, I said we were going to talk about number 9 a little bit. So let's look at this. I'm going to solve the second equation for y. So 2x plus y equals 18. And when I subtract both 2x from each side, I end up with y equals negative 2x plus 18. So that's my substitution. I will substitute that for y in the first equation. 6x plus 3, leave room there for our y value, equals 54. And our y is negative 2x plus 18. And we will need to distribute 6x plus 3 times negative 2 is negative 6. So let's represent that. Negative 6x plus 3 times 18 is 54 equals 54. So if we combine 6x minus 6x, the x's go away. And we end up with 54 equals 54. What's going on? We were not able to solve for x. Well, when you have a solution like this, that means that there's an infinite number of solutions to your system of equations. So let's graph both of those. So that was 6x plus 3y equals 54, and 2x plus y equals 18. And looks like I lost my graph. Okay, that's how I wanted to show it to you. Okay, so I'll turn off the blue graph, and there's my red graph. You can see it crossing the x and y axis. I will turn on my blue graph, and I can't even see the red graph. I turn off the red graph, I've got the light blue graph. Look at that. What happens is they are the same line. Same slope, same y-intercept. So, because they are the same line, every point on the first line is the same as every point on the second line. And there is an infinite number of solutions to the problem. That's what this means. So they are the same line. So why don't you try, let's see, with 2 left, 10 and 11. And a little hint, with number 10, I would solve for x in the first equation. And in number 11, I would solve for y in the first equation. So try them on your own and come back to the video. Okay, let's do number 10. I'm going to solve the first equation for x. So I have x minus 3y equals negative 2. And I just move 3y to the other side. So x equals positive 3y minus 2. And I'm going to substitute that for x in the second equation and solve for y. So 10, and I have to leave room for my 3y minus 2. Plus 8y equals negative 20. Now I distribute 30y, 10 times negative 2 is negative 20, plus 8y equals negative 20. And I combine 30y and 8y to get 38y minus 20 equals negative 20. If I add 20, let's clean that up a little bit. If I add 20 to each side, what's going to happen is the right side of the equation will be worth 0, and the left side of the equation is 38y. Well, if I divide both sides of the equation by 38, I end up with y equals 38 over 0, which means y equals 0. So let's go ahead and take the 0, and we'll substitute it in the first equation, x equals 3y minus 2. I'm going to use the slope-intercept form. So x equals 3, and y is 0, minus 2. And that means that x equals 0 minus 2 or negative 2. So our ordered pair is negative 2, 0. So this is a graph that goes through 0 on the y-axis. So last one, number 11. I would solve this first equation for y. So if you have 3x minus y equals negative 8, I'll move 3x to the other side. Negative y equals negative 3x minus 8. Now I divide everything by negative 1, all three terms. And I end up with y equals 3x plus 8. I like that. Then we're going to substitute that value of y for y in the second equation. And we will solve for x. 5x plus 2. And our y is 3x plus 8. Equals 5. And we distribute. 5x plus 2 times 3 is 6x. 2 times 8 is 16. And the next thing we will do is combine 5x plus 6x for 11x plus 16 equals 5. Subtract 16 from each side of this equation. 11x equals negative 11. Divide both sides by 11. And x equals negative 1. I'm going to take that negative 1 and I'm going to substitute it in this slope-intercept version because that'll be nice and easy. So y equals 3 instead of x, it's negative 1 plus 8. Y equals negative 3 times, or 3 times negative 1 is negative 3 plus 8. So y equals 5. So our ordered pair is negative 1, 5. So that is solving systems of equations using substitution. So let's go ahead and work with our exit ticket. Let's get these steps down in our memory. So step 1, okay, is solve one equation for x or y. The second step is substitute this expression into the other equation and solve for the variable. Because at this point you will only have one variable to solve for because you've substituted the expression. And then number 3, substitute your answer into the revised equation from step 1 and solve for the other variable. I should say from step 1, the other equation from step 1. And then you solve for the other variable. So, I've really thrown a lot at you today, but you guys have been really good about challenging yourself and learning this. Tomorrow we will review this again. We'll compare graphing and substitution tomorrow. But please go ahead and do your homework, because the more you do these, the better you get, and the practice is really good for you, and it just makes you really proficient. I'm so proud of how hard you're working in algebra. Keep up the good work, because you know as you do, you'll be great.